All right, so I want to pick up where we left off with the carbon disulfide molecule. We had drawn two possible Lewis structures for the molecule, and we had calculated the formal charge on each atom. So basically, we had gone through steps 1 through 9 on the handy hints for drawing Lewis dot structures. So now we have to figure out, are both of these structures legitimate? Is one of them better than the other? Well, these are... First, let's read the end part of number 9. So we had talked about calculating formal charge, but notice it says here, try to minimize separated formal charges. It's always better to have lower formal charges, lower magnitude formal charges. So here, when we're comparing this molecule, which has a formal charge of 0 on every atom, versus this molecule, which has 2 non-zero formal charges on the sulfurs, it's clear that this one is going to be preferred. Now, we can also see that in the following step. This is step 10. Determine which resonance forms are preferred according to the following criteria. Aha! So now we have a name for these two structures. These are different resonance forms or resonance structures. So resonance structures are different Lewis dot structures. So different Lewis structures that are both at least semi-legitimate, are both contributors to the truth of the molecule. The question is, which one is more important? So when you're determining which resonance structure is the preferred one, you need to go through steps A through D. So here, let me clean up this mess a little bit here so you can see this. First of all, there should be no incomplete octets. If there are incomplete octets, you know it's not a legitimate resonance structure. Formal charges should be minimized. So that letter B right there tells us that when I am considering the resonance structures for carbon disulfide, the one without the formal charges on the atoms is by far going to be the one that is preferred. Okay, so this resonance structure is going to be preferred due to minimized formal charges. And as we saw, the formal charges on all of the atoms was 0. We did those calculations, 0, 0, and 0. So we don't even have to go any further for this example. In a subsequent example, we will go further and talk about how formal charges should correlate with atom electronegativity trends. What that means is that more electronegative atoms are better able to bear negative formal charges, whereas more electropositive atoms are better able to bear positive formal charges. And finally, if you have to have formal charges, opposite formal charges prefer to be on adjacent atoms. So all of that kind of finalizes the best possible resonance structure for carbon disulfide, which should look like this, with carbon in the middle, double bonds on either side of it connecting to the sulfurs, and then 2 lone pairs on each sulfur atom.